on this screen is reactive. How many people here know of reactive programming in Java? Okay, that's a really good thing. And how many people here are currently doing some sort of reactive programming? That tracks. That's about the right numbers. Okay, so to give you a little background about how I sort of came to reactive programming. I see lots of customers. Those customers generally pay Pivotal quite a lot of money in order to run application instances on Cloud Foundry. But as time went on, we saw the customers were somewhat dismayed about the amount of money that they were paying Pivotal for these AIs, and they wanted to use something a bit more efficient than what they'd been using. They wanted to so most of them were using something like Spring Boot or running a WAR on top of Tomcat, which is sort of the connection to thread kind of linkage. And that meant they'd have a bunch of applications that were running, call it connection bound instead of CPU bound. You'd be paying for a lot of AIs that were sort of 15% utilized and things like that. And they didn't quite like this because obviously it wasn't the most efficient way to spend their money. So what sort of happened was around the time that Java 8 sort of came out, we got everybody in the entire community up onto, sort of a new baseline. We got Lambdas and things like that. The idea of reactive programming sort of showed up. And so I'm going to do a quick level set for everybody, for the few people who don't know what reactive programming is, and say that I believe personally reactive programming is the next frontier if you want to write a highly efficient Java application. When we say efficiency, what we're really saying is given a finite set of resources, whether it be on bare metal, inside of EM, inside of a container or something like that, what do we do to guarantee that we are using those to the utmost, that we are running 100% of the CPU cores that are available to us before we have to scale out and start doing additional instances. And so reactive programming, when we talk about it, it's fundamentally non-blocking. And this is the big change that Java 8 actually brought to us. This idea that we knew we like non-blocking programming models for as long as sort of programming languages have been around. We've known that this idea of when I need to wait for an external system to do something, or even if potentially inside of the same JVM, if I need to wait for something, I want to step away. I want to give the resources that I'm currently holding, which is traditionally a thread in a lot of these cases. I want to give that to someone else to do something useful with. And so reactive programming sort of leverages the Lambda syntax in Java 8 to give us a nice, concise way for us to write code that can take care of this, right? That is fundamentally non-blocking, will execute small sort of atoms of functionality, and when in between those atoms, when we're waiting on something else to happen, someone else can execute on the resources that we have. One of the key things here, though, is that reactive itself has no opinion on asynchronicity, right? So you'll hear reactive and asynchronicity sort of bandied about a lot, but they're not actually tied together particularly well. We see that reactive programming models are a way for you to get asynchronous programming inside of your application, or get asynchronous functionality inside of your application. But the sort of the dirty little secret is if you are writing reactive programs, most of the code that you're writing actually executes completely synchronously because it is the most efficient way. The thread context switch is really, really expensive. So instead what you want is something that knows sort of intelligently, I want to execute synchronously as far as I can, and when it's time for me to wait, I'm going to go off onto another thread, wait asynchronously for a response to come back, and then pick up and do more synchronous stuff. You hear a lot of people sort of bandying about the term reactive and async as if they are equivalent to one another as well. And this is one of the biggest disappointments to me, sort of looking at the Java community, because there is a key differentiator in a way that just being asynchronous isn't enough to be truly reactive, and that's this pull-push back pressure. The reactive stream specification, which we'll talk a little bit more on subsequent slides, has this idea that a producer, a publisher, should not be able to send data faster than a consumer, a subscriber, can consume it, right? Otherwise, you end up sort of flooding that particular consumer. And so we use the term back pressure to say basically the client tells the server, the consumer the subscriber tells the publisher, I don't want you to send me as much data as you're trying to send me. In reality, the way this is implemented is the subscriber has to request additional data. So it says, give me 8 more, give me 8 more, give me 8 more. And that rate, it's not so much a, don't send me quite as much, it's, I'm going to tell you when I'm ready to accept more stuff. And so this back pressure concept is what really differentiates reactive programming from things that are just asynchronous or things that are just non-blocking. And this becomes really, really key when we start comparing projects like R2DBC with other projects that are potentially asynchronous but aren't necessarily reactive. So we said that a lot of our customers didn't want to pay us quite as much as they were paying us previously, and so they wanted something a bit more efficient. And so more efficient is reactive programming. And 3 years ago, it's even earlier than Peter remembers it, we stood on stage at Spring One and we said, here, this reactive thing we think is actually going to be something. We're going to start integrating it into Spring. And then 2 years ago, we said, oh, check out this crazy stuff that we're doing in Spring around reactive programming. We've got this project reactor thing that's, you know, sort of a framework that allows you to implement these reactive programming concepts. And then the year after that, so 1 year ago, we came out with Spring and we said, hey, check out this new thing in Spring 5. This is a reactive web framework. Now you can use a completely non-blocking web stack to transfer data. So we now can break this linkage of a single incoming connection, blocks on a single thread, and you have to have these thread pools of 200, 300, 400, 2,000 maybe threads inside of your JVM to handle loads that would exercise an entire CPU. And so that's basically where we ended up here. The example that we see here uses Reactor, and it uses something from Spring called WebFlux. And WebFlux is sort of the outside. Here is how the that's what I'm looking for. Here is the web tier, right? So we have this composite health method, and we say when somebody calls get/health, we want to execute this thing. We want to return back this mono thing. We'll talk a little bit about that, what that is. But internally, what we see is this thing is trying to do a composite of some other network calls. We want to call the alpha service, we want to call the Bravo service, and whatever the combination of those two things is, we want to actually return that back to the user. And so if you thought about this pre-sort of reactive programming, you'd effectively hold open a thread, at least one thread for the incoming connection. You'd hold open another thread as you've made a call out here. You'd hold open a third thread to go up there. And this is, you know, who knows how long it's going to take Alpha service and Bravo service to respond. This is really, really inefficient. So what reactive programming does in this web client here basically says, okay, I want you to go get me this health thing from these other services, but release all of your threads. And even better, while I'm waiting for you, I want you to release the thread that my incoming connection came in on. And so now we can return back to that original caller, a composite of these two other calls, but we can do it without having occupied 3 threads for the entire time it took to service it. But there are still some roadblocks to this sort of reactive message that we have, right? I put a little star on the idea of reactive everywhere. There are, say, true believers like me and a couple people on the reactive team or the reactor team that do believe that reactive programming is going to be where we all go, right? But this is certainly not an official policy of Spring. It's not an official policy of Pivotal. You shouldn't have to think like this to gain some sort of benefit from using reactive programming. There are certain places, certain use cases where reactive programming is a very obvious win without converting all of your application to use it. So we said there are still a couple of roadblocks. The first one is we don't have the idea of cross-process back pressure. So it's easy enough for me to make an HTTP call out and not block while we're waiting for the HTTP. But imagine if a bunch of data had to be streamed back to me in this direction, right? What exactly stops whoever the sender is, the publisher, from sending me way too much data? We don't have anything to particularly deal with that. Right now, we announced at Spring 1 last year, so this would be the 0th year, that we're working with a couple of companies, including Facebook and Netflix, on a project called RSocket, which sort of takes this idea of pull, push, back pressure, this request to the publisher to send a certain amount of data, but brings it over the network protocol. I'm sure I'll do a Jug talk about this since I lead Pivotal's, or the Spring team and Pivotal's efforts on our socket as well. But then we also had data access. This was the other big tentpole that was preventing people from using reactive programming. And so we knew, sort of a bunch of NoSQL databases especially had adopted reactive programming for this non-blocking kind of behavior. So you can get MongoDB access, Cassandra access, Redis access in a reactive way. And these things performed even better than they would have otherwise because of this. But what we didn't have was sort of a standardized way to do relational database access. And this is, by and large, we all know this, the primary data store for all of our applications, like way over 50% majority. So last year, the Spring team sort of set out to solve these two particular problems. RSoC was one of them, and we have R2DBC here. R2DBC is, at its core, an API designed from the ground up for reactive programming, right? What we want to do is say, okay, relational data access is a really important thing. Let's make sure we have an API designed for doing that. So the design principles themselves are small and pretty concise. So the first is we want to make sure that when we design this API, we always use reactive streams, types, and patterns. So the reactive streams is sort of a collaborative specification. You can go to reactive-streams.org and take a look at it. And it defines sort of a very simple interop API. It has the idea of publishers and subscribers and a couple other less used APIs that allow different implementations, different reactive framework implementations to communicate with this. So it makes it so Reactor can communicate with RxJava, can communicate with Akka and things like that. But we want to make sure we use these particular types, not something else that isn't sort of designed for this reactive programming. We also want to make sure that the API and all the implementations are completely non-blocking all the way to the database. We're going to talk about this a little bit later on when we talk about alternatives to something like R2DBC and why they don't work. But the gist of the situation is you can have reactive non-blocking APIs all over your application, but the moment it touches something that blocks, you just turn away everything, right? It's no longer useful, so you haven't gained any of the benefits you would get, and yet you've still taken on all the complexity of reactive programming. One of the other sort of secondary features of the API is that we want to use wire protocol features where available. I did the implementation for Postgres, and we'll talk about that a little bit later. And it turns out that a lot of these database wire protocols actually have a very similar, or let's say, they were designed to fulfill a lot of the same requirements that reactive programming does in the Java space, this idea that a database should never flood its client. And so it turns out we can go even further than non-blocking all the way to sort of the edge of the JVM. A lot of these wire protocols allow us to go active and non-blocking all the way to the database itself. The third one, and I think one of the most important things here, is this idea of we want to shrink the driver API down to the minimal set of operations that are implementation specific. And then the key bit here, regardless of usability. This is going to seem really counterintuitive, and we'll take a look at it in a bit more detail. But what we want to do is design an SPI that is actually hard for normal users to use, but is really easy for database vendors to implement. Because what we want to do is enable multiple humane APIs, something that humans can use a lot on top of that same API. So the driver SPI, if we think about sort of JDBC to contrast it, one of JDBC's biggest failings, because there are a number of big failings in it, was that the same API was used to serve both the humane side, like what programmers actually had to program to, but it also needed an inhumane API so that alternative clients like JPA and things like that could also use it in a really, really efficient way. And as someone who's used JDBC for 20, 25 years now almost, this leads to an API that basically nobody can use. I've done a lot of work with a bunch of different JDBC driver leads recently, and none of them particularly like the JDBC API. It's a thing they got to do, but it's not great to implement even from their side. So we ended up with a situation where Users didn't like using it, implementers didn't like implementing it, and here we are today. A lot of the problems that the JDBC driver implementers have is that the drivers end up having to duplicate all of the humane affordances that were in there, something like question mark binding and JDBC and stuff like that, is effectively done exactly the same for every single database driver, but they don't share any code to do this, and that's really, really problematic. And I should say, please feel free to interrupt me if I haven't explained something suitably. So let's take a look at the driver SPI. There's, I believe if you went and looked, including all of the interfaces and enums and all of those kinds of things, there's maybe a dozen types in the specification itself. It's really, really small because we want the smallest possible API, even if it's inhumane. And then we are going to skip over the connection factory. We'll take a look at the connection type. The connection factory is pretty simple. It just says, get me a connection, effectively. But even the connection API is really, really small. And if you take a look at it, it talks about the things that are database specific and nothing else. What exactly is the wire protocol, the frames that need to be set across the wire to begin a transaction, or to commit a transaction, or to roll back a transaction? What do we need to send in order to set an isolation level or manage save points or something like that, right? We end up with this really, really, really small, really tight API that's easy for driver implementers to go off and implement. So we see most of the things, transaction management, save point management, some more stuff about transactions down here. And we see these other two, create batch and create statement. And let's skip batch because it looks a lot like what statement looks like. But let's take a look at statement. So once you've said, I want to create a statement, and note there is only one type. JDBC sort of has this old cruft that there's, sort of a callable state. There's a statement, a callable statement, and a prepared statement, which all have some kind of distinction in JDBC, but that distinction doesn't actually exist in databases anymore. Databases have a single wire protocol that you just sort of send something to and you get something back, and whether or not you're doing sort of prepared statement style thing or calling a stored procedure doesn't actually matter in all of these network protocols anymore. So it's sort of this hangover from the way databases were 30 years ago that has sort of crept in and just sort of stays and moves forward with Java. But our statement, we only have a single one of these, has all the things you'd sort of think about. You've created a statement with sort of an SQL expression in it, and we want to bind some data to it, right? We want to bind based on sort of the identifiers that databases are natively using. So on the Postgres side, the bind parameters aren't question marks natively, they're dollar number, so $1, $2, $3, and you can use those. If you use something like Oracle, which uses named parameters, it might be :name, second name, something like that. Bind all of those kinds of things, and then eventually execute. So I've put this final line actually in italics under it. The original version of the API that we started talking about at Spring 1 in August of last year had this particular method in it, execute returning generated key. So this is like doing an insert that returns some auto-generated fields, for example. And one of the weird things is we decided after reflection that this probably wasn't necessary, and we went off and removed it. But as we've sort of been iterating on the API, and this is sort of at the end, I'm going to encourage everybody to be involved, obviously. We had Lucas Etter, who's the head of the Juke project, came and started saying, okay, what happens if I wanted to port onto this, if I wanted to become a client for this API? Could I do what I needed to do? And he came back and told us, actually, no, you're wrong. You actually do need this. And so in the next milestone version of the API, this comes back and is slightly improved. So when you take a statement and you execute the statement after binding data to it and things like that, we end up with basically a single type that gets returned. You get a stream, a flux of, a publisher of results. And so this result thing at the top is for a given SQL query, you can find out how many rows were updated, if that's the kind of thing you were doing, or it has this mapper in it. And this goes back to this sort of functional style API where you're given a row and some metadata about the row, and you are responsible for transforming it into a piece of data that's going to be emitted from that, basically taking a row and mapping a row into a type. Inside of the row is really, really simple. We basically have a way to get based on its columns, right? So here's a column, here's the type I want you to create for me, off you go. There's sort of a default implementation that does its best estimate. All the JDBC drivers, all the database vendors generally have sort of a canonical idea of, given a column of this type in my database, I believe it is this type in Java. And so this sort of makes use of that. If it sees, int4 or something like that, it's going to turn it into an integer, and you don't really need to know much about it to get that done. So let's take a look at use of the API itself. We take a look at the API. We've got this connection factory thing we call create, and we get a connection back. So we see this method called flat map many. This is, actually, let me take a step back. The API itself, if you remember, is defined with a bunch of publishers, right? If we take a look here, there's a bunch of publishers, which are these really, really generic things from reactive streams. This is a thing that emits some kind of data, publisher result, publisher integer, publisher t, things like that. But there is no sort of default implementation of reactive streams. In-house, the Spring team is affiliated, obviously, with Project Reactor. And so that's our implementation. And so you're going to start seeing some operators up here that are Project Reactor specific, but it does sort of translate broadly to any reactive streams compliant implementation. All of this code would translate to those. So we've got our connection factory, we create it, and we take that connection, we create a statement from it, so select value from test, we execute it, and given the result that comes back, we're going to sort of ignore the metadata there, and we're going to say, row, get me the value. And that's all it's going to do. What the result of this thing at the end is, we've taken a single connection, executed the statement, and as the data comes back, we're going to emit what's called a flux, basically a stream, an unbounded stream of data. And it's going to call for every row that came back. It's going to say, emit this type, emit this type, emit this type, emit this type. And then at the end, it will have sort of a lifecycle notification that says, I'm complete. I don't need to send you any more data. And anyone who's listening for that knows that they've now consumed all of those rows. So what happens if we want to do an insert that's more like a prepared statement? Well, we use the exact same APIs as we saw for the select. This time we create the statement, but we'll call bind $1, should be 100, $2 should be 200, so it sort of puts them in the place during the binding. We have this method add that basically says, this is a row, right? This is one insertion that I want to do, and then we'll start another one. Oh. Okay. Okay. So imagine that screen was still there. And if you remember, it said bind, add. Okay. And so that added a row, and then there was a bind, and then an execute at the bottom. There's sort of an implicit add that happens there. And this is how we sort of define. We had one row that we wanted to insert, another row that we wanted to insert. We'd go ahead and execute that, and it returns a result set that might say, here's the number of rows that were inserted. That would be the get rows updated. Or it would return maybe the generated keys if you chose to go in that direction instead. Okay. Okay. I have no idea what that means, but I'll figure it out. Well, I have been hitting the arrow keys to change slides. Yeah. Great projectors we've invested here in Pivotal. Indeed. Yeah, that one joke that I know. Yeah. Is it any happier about that? Oh, now it's actually the fans on and good things look to be happening. Oh, I wasn't going to run over time before, so now if I do, I've got a good excuse. Okay. I mean, yeah. Okay. While they deal with that one, I'll point at this screen over here. Okay, so as we said, bind, bind with an implicit add, and then an execute, okay? But let's say we want to do something even more complex than this. Let's say we want to use transactions. I mean, amazing new invention that we have. We basically have the same structure of this bind, add, except we have to be in a transaction. Then we take that same connection that was handed to us a little bit earlier. So connection begin transaction returns what's called a publisher void, which basically is a signal that this has completed and there is no output. We create a statement, we do a bind, and at the end we do this delay until to make sure we commit the transaction. But if there's an error, we need to make sure to roll back the transaction, then emit the error. So we can do it, but it's a bit verbose, right? Like I designed this thing, and even I think that's a bit not great, right? So let's go back to this design principle. The driver SPI contains the minimal set of operations that are implementation specific and absolutely nothing more. No affordance that's going to make this not suck, right? It's usable, but for those of you who are old enough Java developers, you'll remember try, catch, finally, try, catch, and how every single bug in all of Java was always related to the fact that you did not do try, catch, finally, try, catch in JDBC. So it's remarkable how that has shown up again in my life. So clearly, this API is not humane. What we need is a humane client API. And what we actually need is a lot of humane client APIs. I have some opinions, but if you remember my design back here, I really, really like verbose method names, right? We're not getting charged by the character. We've got autocomplete. I really like that. But you might not. Or like you may enjoy sort of something that's a bit more like JPA. Somebody else might prefer something that's a bit more like Abatis or something like that. So we sort of view this as an opportunity for not just one client API, but for 1,000 client APIs to bloom. Show us what you want to do. And so my implementation, there's sort of a reference implementation client called JDBC client that's checked into a repo in the same organization. Is we've got this thing called with handle. You'll find that this looks a lot like JDBI, which is where I took the inspiration from. We can call a select, and we can map the output of that row. So even that's simpler because we don't have this row metadata. Because certainly you may need the row metadata, and there's an API that'll give it to you, but most people sort of know what their database schema was supposed to look like. They don't actually need to inspect any of the metadata. They know value is going to return an integer. They can say row.get and know they'll get a flux full of integers. The binding, again, with handle, we create this update. We do bind, add. This one doesn't look particularly better. It's sort of the same simple kind of thing. But then we take a look at that transaction, right? We remember all the try, catch, finally try, catch, all that extra code. What if it could be as simple as this, right? Basically exactly the same code we saw before, but we're just going to move all that transactionality around this particular closure. This method even has an override before the closure there that starts handle arrow, where you can set transaction isolation if you want it to always be serializable or read committed or something like that. And this sort of is the promise of the R2DBC API, this strict separation between what a driver implementer needs to implement versus what a client needs to implement. It now allows us to implement a bunch of different clients really, really easily, but not all of them need to have this affordance, this humane affordance around what it means to do a transaction in a reactive way. And maybe you're not even kind of a fan of doing this, right? Like this is still pretty JDBC, like really, really down in the depths of doing SQL and things like that. Most of us these days don't do that. Most of us use repositories like Spring Data repositories or JPA repositories or something like that. What we want to be able to do is have a type that I can say find by last name, passing in a last name, and it's just going to return to me a stream of all of these names, right? Of all of these customer things, right? Again, a different client, sort of a different strategy for accessing data built on something that's really, really small and easy for driver implementers to use. This exists, by the way. This is Spring Data R2DBC, which exists out in the world. So what about some alternatives? So the primary alternative that everybody always tries to do is let's wrap JDBC in a thread pool, right? Reactive down to a thread pool, we sort of fire something off on a thread pool and off it goes. It will wait asynchronously for it to get returned. Well, you've got two bad options when trying to do this. The first is when you start firing in requests, you've got a ton of load coming in because obviously you're non-blocking at the web tier, which means now you can handle 10,000 simultaneous connections, 20,000 simultaneous connections. Like we're talking many orders of magnitude more than you might with a standard blocking strategy. You have a queue while it waits for the database to respond. That queue can either be unbounded, which means you're effectively going to grow until the JVM completely runs out of memory, or you can put a bounded queue in there, which will guarantee that your JVM won't crash. But on the other hand, you now have blocking insertions, and you're right back to the same blocking API you had before. So the second API, or the second option is ADBA, which is the elephant emoji in the room, right? ADBA is Oracle's attempt, let's say the Java specification, which happens to be mostly managed by Oracle, to put asynchronous database access in. So there's just sort of a spec that they're looking sort of long future. As of Oracle Code 1 this year, they're sort of thinking Java 17 will probably be where it sort of makes LTS releases. I mean, I know 17 is a big number considering like in my career, we went from like 4 to 8 or something like that. But it's not as far away as you think it is, but it's still multiple years away, which isn't great considering we need this sort of high efficiency programming model now. They've gone down the path of asynchronous is sufficient. We don't believe that's true. We believe ADBA, rather than being based on completable future, which is just purely asynchronous and doesn't have any of the push-pull back pressure, doesn't have any of the lazy initialization, they should actually be building on top of Java 9's flow, which is, for all intents and purposes, exactly reactive streams. Like, there is not only this reactive streams specification that there are 4 viable implementations of that are really highly performant and well-proven and integrated into Spring and things like that. There's even a perfect equivalent of that API in Java today that just is never used, right? It's perfect for ADBA to use something like that. So we don't think the API actually gives us what we need with regards to reactive behaviors. And then there is also the horrible problem that the only functional implementations are Oracle and an API adapter called ADBA over JDBC, which doesn't actually give you any of the asynchronous behavior. It basically just delegates to blocking JDBC drivers under the hood, but allows you to use ADBA's API instead. So there isn't even a good implementation of this out there in the world. R2DBC, on the other hand, what can we do today? Well, R2DBC itself is, we sort of consider this an umbrella brand, and it sits on top of the SPI. It sits on top of some implementations, some clients, some other additional auxiliary libraries that are going to go around it. We consider it to be alpha quality. When we started talking about this 3 or 4 months ago at Spring 1, we consider it to be experimental and nobody should use it. Now it's alpha quality. It's great for testing. Like, we're really high quality developers. There aren't just going to be a bunch of bugs lying around in it. It's relatively bug free, but under no circumstances should be using something like this in production today. But already out of the box today, we have implementations for H2, Microsoft SQL, Postgres, and we even have, because you got to have one of these things, an API adapter layer that will adapt R2DBC to ADBA, at which point you can plug in Oracle's ADBA, or you can plug in ADBA over JDBC, and plug in a JDBC driver, and just have this chain of horribleness that ends in blocking JDBC in the end anyway. For each one of these implementations, you can already do batching, extensive type conversions. So in the Postgres one, we can convert about 40 or 50 different types from their list of column names. It's somewhat variable depending on whether you're looking at the Microsoft one or the H2 one, exactly how many they have, but it's relatively broad. We have save points, transactions, and transaction isolation for every single one of these. We try and keep them in lockstep as far as feature parity. On the client implementation side, we have Spring Data R2DBC, which is obviously the most compelling one. Everybody likes just an interface where I can ask for a flux of customers, but we have the R2DBC client as well. And as I said a little bit earlier, some of the other sort of JDBC wrapper clients are sniffing around and investigating implementations at this time as well. So always have to, because my corporate overlords require me to, put a safe harbor statement in here, which basically says I'm about to tell you about stuff that doesn't exist yet. Don't hold Pivotal liable for what I say here. What do we want to do? We want to do continuing additions and improvements to the SPI. If you take a look through the SPI's GitHub issues, we have blobs and clobs coming up next, service-based driver selections. We're not going to use URIs, which are these sort of weirdly formatted strings. We're going to do something a little bit better than that, but you'll basically be able to say, here is some configuration metadata. Go find me the correct database driver somewhere in my class path soup and give me that database driver back. Observability, which is, I believe, the very first issue that was sort of opened by an external party. We consider observability to be a primary design goal of R2DBC in a way it never was for JDBC, so that you have some idea of like what the performance is, or being able to trace from the top of the web tier all the way down to where you execute into the database. We also want some additional implementations. We've got a line. There's a guy who works at Pivotal, a bit of a nerd who did his master's thesis on a deep analysis of the MySQL wire protocol. So we're pretty sure he can come and implement that for us. Once we can shake him free of his other team, we're engaged with both IBM and Microsoft directly for them to have input, and sort of ideally, sort of many years down the line, we want the database vendors to take these over if we can prove R2DBC to be a viable project. We still need connection pooling. You'd be amazed how well this performs even without connection pooling, but we know that connection pooling is a really important thing. So there's sort of this generic project going on under the Reactor umbrella to have a completely non-blocking pooling system, just generic object pool. So that's going to be really good as well. And we would really, really like at least one additional client, so someone else to sort of be banging on the API from above, telling us the things that we're missing, or telling us how things don't work, or that we haven't defined the contract strictly enough, something like that. And then I say, sort of long term, my ideal situation, because I would actually like to see my wife again, and I don't want to have to program on the weekends for the rest of my life, I really want R2DBC to influence ADBA itself. I want it to become the Java specification for asynchronous access to databases. I want it to be cared for by somebody else and adopted by the community. But don't get me wrong, like, we don't create specs on the Spring team, but if ADBA is not good, like, we don't just sit around and assume that that's fine. We're going to make this a thing if we can't get a good official spec for it. So some resources, the website, R2DBCIO, Twitter, we've got a handle, GitHub. Please, everybody, I can't encourage you enough. We try and be as inclusive as possible with the community. One of the things that was really surprising to me, so the way R2DBC happened was at Spring 1 a couple years ago, at every Spring 1, because the Spring team is so geographically distributed, we almost never see one another. Some of my best friends on the team, I see for 3 days every year for the last 10 years kind of thing. And yet we're great friends. But one of the interesting things is after Spring 1 every year, we have this big engineering meeting. And so sort of we were at one of these Spring 1s, somebody said the letters R2DBC and said, what might this be like? And a couple months passed, nothing really happened. I was at my in-laws' house, and I'm not super fans of my in-laws, and so I didn't want to actually spend time with them. And so I sat down and said, okay, what could this look like? And I went off and implemented it. And I think the biggest sort of learning experience to me was that database drivers aren't impossible. I've got 20 years of Java experience or whatever I said. And I often assumed that JDBC implementers were geniuses, but they don't have to be. It turns out that these wire protocols are relatively easy to understand. The code inside of a JDBC driver is relatively easy to understand. You can just implement one. So if you have a database that you like that I haven't talked about or that we don't have a line into the company, like you can just implement one of these drivers. Talk to us in the R2DBC community. We'll help you get started. We'll make you the lead of a project, and off you go from there. We've got a mailing list that's public so that everybody can contribute. And one of the things I really quite like is we have a wide open weekly call. You can go to the R2DBC website for the dial-in information. But every Friday at 6:30 this time zone, so I bet not many of you really want to get up for that, we sort of have an R2DBC spec meeting where we talk about, like right before Christmas, we had a guy who wrote sort of a proxy around it, the R2DBC, what will eventually become the R2DBC proxy, on his own time. He said, I wanted observability into this, and this is how I thought we could do it. Can you make this change to R2DBC for me? And we said, oh yeah, not only can we do that, but why don't you take that project that's in your private repo and become part of the R2DBC organization? And now everybody gets observability and serviceability inside of the project. So I'm really, really proud about that particular bit of it, but please, get engaged. If this is something you're interested in, we're really, really inviting. Obviously, we have a ton of experience running open source projects, and we have, a fair amount of momentum behind this particular one. Okay, so thank you, everybody. That's it. Any questions while I'm standing up here and mic'd? I'm happy to take questions over pizza and dessert and stuff like that. There you go. How about here in the blue over here? Okay, there we go.
So have you run any perf tests to show sort of before and after?
Right, so have we run any performance tests? At this time, no. One of the things that we do know, so on one of the slides I said there's basically no reactive database access anywhere in the world. And that's not technically true. We have sort of found prior art over time that there are 3 or 4 reactive drivers for Postgres only, right? They're not designed to be sort of like a spec that's broadly applicable to a bunch of databases. There aren't a bunch of implementations of them. We are engaged with those particular projects and bringing them in. And so they have done performance testing, and we're engaged really heavily with the Postgres community simply because we started there. And they've pointed out that by nearly an order of magnitude, the highest performing Postgres driver in any language is the Vertex reactive Postgres driver. So we haven't done any performance testing. We're still early enough that we're sort of leaning on that particular thing, but it is something that comes up in our calls and comes up when we talk to Microsoft. We know it immediately performs better simply inside of a single JVM because it is non-blocking. So from an efficiency standpoint, we can now handle 10,000 simultaneous connections in a way we weren't before, but we don't have hard numbers yet for that. But it is sort of right there next to making sure there's a TCK for all of this thing, having a performance benchmark that we can do, start publishing into other sort of mainstream benchmarks as well. Yeah, and then the blue shirt there.
You said you work directly with Juke. Do you think they'll have a client out soon?
Client out soon? No. I know Lucas is experimenting with it, but he's sort of in the position of all of the database vendors themselves. Like, what is this R2DBC thing, right? Like, it's this something that somebody did at their in-laws' house because they were antisocial. And so he's there providing a lot of input back to us saying, like, if I wanted to implement it, I need this, this, and this. Or you remove this API, but here is the way we use it that is actually useful. And so if I had to guess, that is the candidate for the next implementation, but I would not guess when exactly that's going to be. back there.
Hi. Couple questions. So what about scheduling? Since it's full non-blocking down to the network, do you expect users to apply any schedulers whatsoever, or like whatever thread got the request, let's say from your like Spring Web request handler, just like scheduling that?
Yeah, so when it comes to scheduling incoming requests back in, we lean a lot on, so because we're a Reactor house, we lean a lot on Reactor's built-in schedulers and then Reactor Netty's built-in scheduler. And so it does things like thread stealing to sort of optimize and reduce the number of context switches, but in the end, we're sort of subject to the event loop that Netty uses. But that's just an implementation choice that we've made. If you wanted to go off and implement a competing Postgres one that's based on something that's not Netty, I don't even know what's not Netty in Java and still non-blocking networking, that has sort of a different scheduler behavior, you'd be free to do something like that. Yeah.
And talking about Netty, so down to the socket, we need to talk non-blocking too, which is either Java non-blocking IO or like EPOL, KQ, and whatnot. What does your implementation use right now?
What was the question right at the end?
So like what does your implementation use right now? Does it use like NIO or does it use like Netty, EPOL or something?
Yeah, so we're Netty all the way down, and where Netty ends and does its sort of non-blocking event loop. I still believe it's based on NIO. Maybe it's not. Maybe it's based on sockets.
EPOL.
Yeah, there you go. Yeah, the default stuff down there. But again, like that's the implementation we've chosen, and it seems to perform pretty well because it's also the implementation we use in Spring Webflux up at the other end to serve stuff out. And so we're pretty confident with that particular implementation. But again, the spec itself isn't opinionated in that. Yeah. Oh.
Can you show us more code?
Can I show you more code? It's almost like I have an IDE already open for this. Let's go to presentation mode. Okay, so probably the best thing to look at for this is we have examples. This is sort of, let's call it our TCK before TCK. We have sort of a general set of examples to prove that all of the functionality we think works, and we expect all of the implementations to run and pass against this. And so everything from like doing compound statements, what does it mean to put something with a semicolon in it? And the answer is that you effectively get the result of this is actually a flux of publishers instead, which you then parse out and you can take a look inside. And there's some really, really complicated stuff if you eventually get in there, like how we deal with save points. So you can sort of see the beginning of the transaction, executing and extracting some data. And even that data is, sort of asserted down here. That's the data that fell through. Then we did an insertion that followed from there. I extracted some data from it. We created a save point here, ran another insertion and guaranteed that the data was there, and then eventually rolled back the save point, guaranteed the data wasn't there, and then sort of collected and closed it all out. But again, like this particular example isn't great in the sense that this is us testing that inhumane SPI works, and that's why it ends up being a little bit wordy. And so there's another set of examples up in the client that do effectively exactly the same stuff. So I think the save point stuff is in here, which has a different look, but is exactly the same thing and hopefully a little bit more humane in the sense that, sort of transaction management happens up here, but we do that execute. There's, unfortunately, because we have to support like H2, which uses question mark, and this test is supposed to work for that, and Postgres, which is $1, and I can't even remember what the MS SQL one is. We have some sort of complexity around formatting strings and stuff. But the key here is, here's an insertion, here's where we select and extract some data from it, set a save point, insert and select that data was there, roll it back, do another select to guarantee that it's not there anymore. And then sort of all the sort of transaction commits. And I'll go back to, I think as much as you don't really want to ever write this code, the more interesting code for me is always what it looks like to use the SPI, because it's sort of exposed a little bit more exactly what you're doing there. But again, it's complex. We expect something a little bit simpler to build on top of it. Again, like realistically today, we see everybody leaning towards something like JPA or Spring Data repositories, where you just ask for a flux of things, and then the client executes all the SQL necessary to return the rich types that you're asking for.
A couple more questions. Did you decide to put years as part of specification because they're like not typed in reactive streams? So
Yeah.
You don't know which types of years to expect?
Right. So there is an R2DBC exception that everything comes out from. We expect it to be a hierarchy. The Spring team is really big on this, right? Because SQL exception in JDBC was horrible and it wasn't extended, or like it was just this generic bag, and they have to, there's a giant XML file in Spring, like thousands of lines long, that has all of the mappings from, given this database and this SQL error code, it's actually this kind of rich exception. And so we know that that's something we should do, but it then ends up being sort of database specific to extend from there. There is an R2DBC exception. We'll probably have some broad categories, like there should be an authentication exception, and maybe, I don't know, we'll see where we go from there. But we would expect the database driver implementers to have a richer subset from there. So a light spec of exceptions so that it's not quite as bad, but I don't think we can go very deep because databases are so different.
What if some driver doesn't support back pressure? So like you ask it to give me like, I don't know, 1,000 rows, and it just like splits all of them right away.
Yeah, so drivers cannot do that, right? Because to return a publisher is to return a compliant publisher that always has back pressure. You may choose RX Java or something like that. Where you can end up with problems is when you ask the database for data,
right, that's
and
what
it
I
might
meant.
strange,
Yeah.
It might send a bunch of data. Actually, the first implementation of the Postgres one was this, and it turns out that TCP back pressure is sufficient because Netty's not pulling packets off the network and forcing them and allowing them up. And so you get TCP back pressure, which helps right there. But we want to do better than that, because one of the really nice things about pushing back pressure down through the wire protocol is, imagine you did a query for 10,000 rows or something like that, or 10 million rows, and you receive the first 1,000 of them. If I said, okay, now I want the first 1,000, then I want the second 1,000, then I want the third 1,000, the data that's actually going to be sent to you, the way databases are implemented, won't even be materialized off the disks, right? It'll never be read from the hard disk. It'll never be read into the database process until you request that next set of stuff. Versus if I just depend on TCP back pressure, I've got to do this request, and it's going to read as much data as quickly as possible off of disks and fill both your TCP queue and its own outbound TCP queue as much as it can. And so it's not just sort of good for the client side to be able to do this. It actually reduces the load on the databases themselves. And so one of the Facebook has something like this internally based on C++ because they're Facebook. And what they see is simply using our socket across the network and then using something like R2DBC for their database access, like significantly, like tens and tens of % drops their database load levels, which is good just sort of all around. It allows more concurrent users onto a given instance as well. That's a really good question, that one. Okay. Then I will call it a presentation, and I'll stand up here not on the mic, and we can talk for another 30 minutes. Okay? Thanks, everybody.